So section 3 is going to take all the mechanical things that we learned about solving systems of equations and apply them to problems that don't give you a direct system to solve. So what we see here is we're going to see a problem and we have to create a system against it and use the processes that we've learned that allow us to create a system. So this first problem says a motorboat traveling with a current can go 24 miles in 2 hours. So if we're going to talk about something like this, I'm just going to go ahead and draw a picture with a current. So we're talking about something that's going with the current. And against the current, we're talking about something that goes the same distance. Well, this is our formula for distance. It's rate times time. So to find this, we know the distance in each case. So that's 24. So we're talking about an equation that we can use with the current, and we're talking about one against the current. We have a time for each one of these. Okay? For the first one that is with the current, we know that the time is 2 hours. The problem is that the current is the result of the speed of the boat and the water. So I'm going to write R plus W. Because you add the speed of the water to the boat, that increases the speed. Now, for the speed of the boat against the current, we're still using the same formula except for the fact that it's taking 3 hours now, and instead of adding the water, we have to take that speed against it and subtract it. So what we have here, even though it doesn't look like it because we have these parentheses, we have a system. And it looks like this. And again, R is the speed of the boat. W is the speed of the water. Okay, so we have this system, we should solve it. Using elimination, I'm going to get rid of the water because they're already opposites. I'm going to times this one by 2, or excuse me, by 3. I'm going to times this one by 2. So what I get is 72 equals 6R plus 6W. And in the second equation, I get 48 equals 6R minus 6W. Notice that they're the opposites, so I'm going to add these two equations together. So if I add these two equations together, I get 120 equals 12R. That cancels out. So if I divide by 12, I get R is equal to 10. So R is the speed of the boat. So that's 10 miles per hour. So now we just need to figure out what the speed of the water is. Well, if it takes 24 miles in 2 hours, in 2 hours the boat alone would go 20 miles. So that means that the water, if I plug 10 in here, that would mean that it's 20 miles. So I have to compensate for that by adding another 4. So that means the speed of the water, if I plug it in and solve for W, would be 2 miles per hour. Flying with the wind, a plane flew 1,000 miles in 5 hours. Flying against the wind, the plane could only fly 500 miles in the same amount of time. So again, this is a distance problem with the wind. We have a distance and we have a time, but we don't have a rate. We have a rate plus a wind. Against the wind, it could only fly 500 miles, so this is against the wind, in the exact same amount of time. But again, the wind is now not a part of the speed. It's a part of the speed that we subtract. So there is our two equations. It's 1,000 equals 5R plus 5W. 500 equals 5R minus 5W. And from here, if you notice something already, if you want to solve this, notice that the W's are already the same coefficient but opposites of each other. So I don't even need to multiply by anything. I can just eliminate them. So I'm just going to add them right away. So I have 1,500 equals 10R. Divide by 10. I get R is equal to 150. So the rate of the plane is 150 miles per hour. If I plug that in, I get 1,000 equals 150 times 5 is 750 plus 5W. If I solve this, I get 250 equals 5W. So that means the wind has a speed of 50 miles an hour. So the rate of that plane in column air is 150 miles an hour. The rate of the wind is 50 miles an hour. Now for the next problem, I have some things underlined, and for the second part of the video, I'm actually going to change this to a different video. But it says a store owner purchased 20 60-watt bulbs and 30 fluorescent bulbs for a total cost of $80. A second purchase at the same prices, meaning that the prices of the two things were the same, purchased 30 60-watt bulbs and 10 fluorescent bulbs for a total cost of $50. Find the cost of each thing. Well, this problem, and what I should always start by doing, and what you should start by doing with these, if you're not using a formula, is ask yourself, what is it that you're trying to find? And X is saying, I want to find the price of something. And let's say we're trying to find a 60-watt light bulb price. And Y is going to be asking the price of a fluorescent bulb. Okay? Now we have to create two different equations. And if you see that this person has two purchases, so the natural thing to do is to talk about these two equations as a result of each purchase. So the first purchase is going to be a result of how much he purchased. He purchased 20 of the 60-watt bulbs. Now this is going to be a price because it's asking find the cost. So these are prices. So the first purchase, he purchased 20 of these 60-watt bulbs. So if you take 20 times the price of them, you get how much they're equal to. And 30 fluorescent bulbs. And that's going to give you a total cost of 80. So now we have to do the same thing for the second purchase. The second purchase had 30 60-watt bulbs, so 30 times the price of them, plus 10 fluorescent bulbs for a total cost of 50. So there's my two equations, and I can solve these substitution, elimination, it doesn't matter. But I'm going to times these two equations by a -3, or by the second equation by a -3. So I get 20x plus 30y equals 80, negative 90x minus 30y equals a -50, or negative 150. So if I combine the two equations by adding them, I get negative 70x, these cancel, equals negative 70. Divide by a negative 70 again, gives me the price of one bulb for a 60-watt bulb, and that is $1. It's $1 for a 60-watt bulb. So if it costs $1 for a 60-watt bulb, that means you spent in the first purchase $20. That means you have $60 left to spend for the entire 80. And if you bought 30 of them, if you plug this in, y is going to have to be 2. And if you want to see the whole thing out, 20 times 1 is 20, plus 30y equals 80. Again, I plugged 1 in for x, minus 20. I get 30y equals 60. Divide by 30. I get y is equal to 2. So the price of this bulb is $2. So the price of each bulb, $1 and $2.